Now we'll come to equation of a plane. Now we already know in 3 dimension, equation of a plane will be a linear equation. Say ax plus by plus cz plus d equals to 0, where direction ratios of normal, they are a, b and c. Now the first equation of plane is normal form. And in the normal form, what we are given is, we are given direction cosines of normal L, M and N, and we are also given perpendicular distance from origin. So this perpendicular distance from origin, it is say D. Now any general point on this plane, we can write it as XYZ. Now projection of OP on this normal will be equal to D, and we know that this projection is x2 minus x1. Now in this case it is x minus 0 into L plus M into y minus 0 plus N into Z minus 0, and it must be equal to D. So equation of plane in normal form is given by Lx plus My plus Nz, and it is equal to D, where L, M and N, they are direction cosines and not direction ratio, because we need a unit vector in this direction, and D is perpendicular distance from origin. So say for example, a plane which is at a distance of 3 units and whose normal is in the direction of 2, minus 2 and 1 will be given by direction cosines. They will be 2 by 3, minus 2 by 3 and 1 by 3. So these are L, M and N, and that's our perpendicular distance from origin. So this equation is 2 by 3x minus 2 by 3y plus 1 by 3z, and it is equal to 3, or we can write this as 2x minus 2y plus z equals 9. So this is the equation of required plane. We can also express this equation in vector form. So suppose we have normal of this plane as n cap. So a unit vector in the direction normal is n cap, and perpendicular distance from origin, it is D. Then any general point which is vector r, xi plus yj plus zk, then projection of r in the direction of n will be equal to D. So equation of plane will be r dot n cap equals D. So that is the equation in vector form. Now for the same question, n cap is 2i minus 2j plus k whole divided by 3, and perpendicular distance is 3 units. So we can also write this equation as r dot n cap. So it will be this 2i minus 2j plus k by 3, and it will be equal to 3. So this is the equation of plane in normal form. Now from any general equation of plane which is ax plus by plus cz equals d, we can work out normal form. And for this, what we need to do is, since this d, it represents perpendicular distance, we have to make this positive. So if there is a negative sign here, we'll take it on the left hand side, and then here we need to make them as direction cosine. So we'll divide everything with under root a square plus b square plus c square. So we can write a upon under root of a square plus b square plus c square x plus b upon under root of a square plus b square plus c square y plus c upon under root of a square plus b square plus c square z, and it will be d upon under root of a square plus b square plus c square. Now this is L, M, this is N, and this is a perpendicular distance from origin. So this is your distance from origin. So we can convert any equation in normal form. So say for example, suppose we have this plane which is x minus y minus 2z equals minus 3. Now we have to change it in normal form. We'll take this minus sign on the left hand side. So we'll write minus x plus y plus 2z equals 3. Now a is minus 1, b is 1 and c is 2. Under root of a square plus b square plus c square, there will be root 6. So we'll divide everything with the root 6. So it will be 1 by root 6 x plus 1 by root 6 y plus 2 by root 6 z, and it will be 3 by root 6. So direction cosines of normal to this plane, they are minus 1 by root 6 plus 1 by root 6 and 2 by root 6, and perpendicular distance from origin is 3 by under root 6. And if you want, we can write this equation in vector form also. So this is r dot, now this is your n cap, minus 1 by root 6i plus 1 by root 6j plus 2 by root 6k, and it is equal to 3 by under root 6. Now this second equation of plane is perhaps the one which we are going to use more often. If we are given this plane whose normal is characterized by direction ratios a, b and c. So here we need not have direction cosines, direction ratios are fine. So direction ratios of normal are a, b and c, and we have a point on this plane which is x1, y1 and z1. Now we need to find equation of this plane. So what we are given is, we are given a point and direction ratios of normal, and we need to find equation of this plane. Now any general point on this plane will be given by this x, y, z. Now we can define this vector as this AP, and direction ratios of AP, they are x minus x1, y minus y1 and z minus z1, and direction ratios of normal, they are a, b and c. Now basically any vector in the plane and normal, they'll be perpendicular. So their dot product, it must be 0. So we'll get a into x minus x1 plus b into y minus y1 plus c into z minus z1, and it must be equal to 0. So that is the equation of plane in Cartesian form if we are given a point and direction ratios. If we have to write vector equation, so for that we are given a point, say A, whose position vector is A, then we are given normal to this plane which is say n. Any general point, it is given by this r which is xi plus yj plus zk. Then this vector AP will be r minus a, and is perpendicular to n. So from here we can write r minus a dot n cap equals 0, or r dot n equals a dot n. So that is the equation of plane in vector form. Now say for example, we need to find equation of plane which passes through the point 2, minus 1 and 3, and whose normal is in the direction of vector 2i plus 2j and minus k. Now in this case we have a point, and this point is 2, minus 1, 3, and we have direction ratios which are 2, 2 and minus 1. Now equation is a into x minus x1, so it will be 2 into x minus 2 plus b into y minus y1 and plus c into z minus z1. Now this equation will be 2x minus 4 plus 2y plus 2 minus z plus 3 equals 0, or we can write this as 2x plus 2y minus z, and here it is 3 plus 2 5, 5 minus 4 1, so it will be equal to minus 1, and that is the equation of this plane. Now we have to write this equation in vector form. Here n is 2i plus 2j minus k, and point is a which is 2i minus j plus 3k. Then equation of plane is r dot n equals a dot n. Now r is r and n is 2i plus 2j minus k, and it will be equal to a dot n, and a dot n is 4 minus 2 minus 3 which is minus 1. So equation of this plane in vector form is r dot 2i plus 2j minus k, and is equal to minus 1. So we can write this equation in Cartesian form as well as in vector form. And it is very easy to change equation from one form to another. Now suppose we have any equation which is ax plus by plus cz equals d. Now this is your normal ABC, and xyz it is r. So basically we'll write this as r dot ai plus bj plus ck equals d. So for this plane we can directly write it as r dot, and it will be 2i plus 2j minus k, and it is equal to minus 1, which is same. And if we have vector equation, then this r is nothing but xi plus yj plus zk, and if we take this dot product, we can write ax plus by plus cz equals d. So in this equation, if we take this r as xi plus yj plus zk, and if we take this dot product, we can write 2x plus 2y minus z equals minus 1, which is same as this equation. Now basically, in order to write equation of plane, we need a point and a normal. And since this normal, it is perpendicular to this plane, so at times what we'll need is, we'll need two vectors in the plane, say b1 and b2, and a point which is a, to write equation of this plane. So we can write this equation as r minus a dot n, and n is given by b1 cross b2. So for all such questions where we are given two parallel vectors b1 and b2 and a point in the plane, we are going to write this equation directly, and we'll write this equation in terms of a point which is say x1, y1, z1, and two parallel vectors say a1, b1, c1 and a2, b2, c2. Then this box product r minus a dot b1 cross b2, it must be 0. So we can write this determinant as x minus x1, y minus y1, z minus z1. Now this is a1, b1, c1, and this is a2, b2 and c2, and it must be equal to 0. So there will be many cases where we'll be given two parallel vectors, and then using this point and cross product of these vectors, we can write equation of this plane, and we'll write it directly using this determinant. So there could be cases where we'll be given two lines in a plane. Say for example, this is x minus x1 upon a1, y minus y1 upon b1 equals z minus z1 upon c1, and here it is x minus x2 upon a2, y minus y2 upon b2, and z minus z2 upon c2. We have to write equation of this plane. We need a point, so either we can take this point from this first line, or we can take it from second line. It doesn't matter. So we'll take up this point, so it will be x minus x1, y minus y1, and z minus z1, and a vector in the direction of first line, it is a1, b1, c1, and the second line, it is a2, b2 and c2. So we'll write this as a1, b1, c1, and a2, b2 and c2, and it'll be equal to 0. Or it could be find equation of plane passing through some point, say x1, y1, z1, and it is parallel to two vectors which are a1i plus b1j plus c1k and a2i plus b2j plus c2k. Again we have this point, so we'll write x minus x1, y minus y1, z minus z1, and then since we have two parallel vectors, we can find its normal taking cross product. So we'll write a1, b1, c1, a2, b2 and c2. Now we can also have this condition when we are given 3 points in the plane, say a, b and c. Now this is x1, y1, z1. This is say x2, y2, z2, and this is x3, y3 and z3. Now in order to write equation of this plane, we'll take up any one point, say x minus x1, y minus y1, z minus z1, and then we need two vectors in the plane or two vectors parallel to the plane. We can define vectors in terms of direction ratios. Say x2 minus x1, y2 minus y1, z2 minus z1, and x3 minus x1, y3 minus y1, and z3 minus z1, and it must be equal to 0. So again we can calculate equation of this plane directly using this determinant. Another question could be, we need to find equation of plane containing a given line, which is say x minus x1 upon a1, y minus y1 upon b1, and z minus z1 upon c1, and we are given a point in the plane which is say x2, y2, and z2. Now we can write this equation using this point or the other point. So it will be x minus x1, y minus y1, z minus z1, and then we have this one vector which is a1, b1, c1. Now we need one more vector in this direction, and we'll get this vector from the two given points. This is x1, y1, z1, and this is x2, y2, z2. So direction ratio of this line, there will be x2 minus x1, y2 minus y1, and z2 minus z1. And if we put it equals to 0, we'll get equation of this plane. So there will be many cases where we'll be given this point and two vectors parallel to the plane. Then we'll write equation of this plane directly using this shortcut. Now the fourth equation of plane is parametric form. Now if we have a plane which passes through a point, say A, and then we have two parallel vectors in the plane, say B and C, then one way of writing this equation is R minus A dot B cross C equals 0, which is basically our shortcut in this third equation. Another way to write this equation is R equals this A plus lambda B plus mu C. So this is parametric equation of this plane, where A is a point on this plane and B and C are vectors parallel to the plane. So we can write equation of this plane as R equals vector A plus lambda vector B plus mu C. Now basically we get this equation from this first portion itself. Now R minus A dot B cross C is 0. That means R minus A, it is perpendicular to B cross C, or R minus A is coplanar with B and C. And we know that if B and C are non-collinear vectors, then any vector in the plane of B and C, they can be expressed as linear combinations of B and C. So linear combination of B and C, it is lambda B plus mu C, and thus we get this equation as R equals A plus lambda B plus mu C. Negative questions. Find the equation of plane passing through these 2 points and parallel to x-axis. Now we are given this point, so we can write this shortcut. So it will be x minus 2, y minus 2, z minus 1, and then two parallel vectors. Now one parallel vector we'll get from these 2 points. So it will be 2 minus 1, 1, 2 and minus of minus 2 plus 4, and this is minus 2, and then it is parallel to x-axis, and x-axis direction ratios are 1, 0, 0. So it will be 1, 0, 0, and it should be equal to 0. Now we expand it about this third row, we'll get this as minus 2y plus 4 minus 4z plus 4 equals 0. So this equation will be y plus 2z minus 4 equals 0, and that is the answer to this question. Now the question is, we are given 3 points P, Q and R, and the first question is find PQ cross PR. Now first we'll find this vector PQ. Vector PQ is Q minus P, so it will be 0i plus j plus k, and then this vector PR, it is R minus P, so it will be minus 3i plus j and plus 3k. Now we take their cross product, we can write PQ cross PR will be this IJK 0, 1, 1 minus 3, 1 and 3. Now this is 3 minus 1, so it will be 2I and then minus 3J and plus 3K. So that's our part A. Now we'll come to this part B. It says find the equation of plane in scalar dot product form. Now since we are talking about this plane which passes through P, Q and R, it's normal, it will be perpendicular to the plane and will be given by cross product of PQ and PR. So this is nothing but this is our end. So we can write direction ratios of normal as 2I minus 3J plus 3K, and we know that equation of plane in vector form will be given by R dot n and it will be equal to A dot n, where A is any point on this plane. Now n in this case is 2I minus 3J plus 3K, so we can write R dot 2I minus 3J plus 3K, and then it will be A. A is any point. Let this point be I plus J minus K dot 2I minus 3J plus 3K. So we can write this equation as R dot 2I minus 3J plus 3K, and here will be this 2 minus 3 and minus 3, so it will be nothing but minus 4. So this is the equation of plane in scalar dot product form. Now the next one is find the equation of this plane in parametric form. Now for parametric form, what we need is we need a point which is say A and then two parallel vectors in this plane, say B and C. Now here we have this point which is I plus J minus K, and we have two parallel vectors PQ and PR. We can write equation of this plane as R equals A, and A is this point which is I plus J minus K and plus lambda PQ which is J plus K and plus mu which is minus 3I plus J and plus 3K. So this is the equation of plane in parametric form. So we have scalar dot product form and we also have parametric form. Now this third one is we need to write this equation in Cartesian form. Now for Cartesian form, what we'll simply do is we'll write this R as xi plus yj plus zk. Now we write this R as xi plus yj plus zk. We can write this equation as 2x minus 3y plus 3z plus 4 equals to 0, which is Cartesian equation of this plane. And that's your third part. Next the question is find the point R on this line AB which cuts the plane CDE, where we are given points A, B, C, D and E. Now we'll find vector AB. Now vector AB is B minus A, and B minus A will be 2I minus I, which is I, J minus 2J, so it will be minus J, and 2K minus K will be plus K. So we can write equation of this line AB as R equals A, which is I plus 2J plus K plus lambda AB. So it will be I minus J plus K. So we can write this line as 1 plus lambda I, 2 minus lambda J and 1 plus lambda K. So this is equation of this line AB. Now any point on this line, we can write this as 1 plus lambda, 2 minus lambda and 1 plus lambda. So this is any general point on this line. Now we'll come to equation of this plane CDE. Now for this, what we'll do is we'll find this vector CD. Now CD is D minus C. Now this is 2I. Now this is minus 2J and then plus 4J. So it will be plus 2J, 2K minus 4K. So it will be minus 2K. So direction ratios of CD will be 1, 1 and minus 1. Now we'll find direction ratio of another parallel vector, say DE. Now DE is E minus D, so it will be 2i. Now this is j plus 2j. There will be 3j, and then 2k minus 2k is simply 0k. So direction ratios of DE, they are 2, 3 and 0. Now we can write equation of this plane. The equation of this plane will be x minus x1, y minus y1, z minus z1, and for this we'll take this point as 0, minus 4 and 4. So it will be x, y plus 4, z minus 4. This is 1, 1, minus 1, and this is 2, 3 and 0. Now we'll expand this determinant. So this is 0 plus 3. So it is 3x. Now it is 0 plus 2. So we'll minus 2, y plus 4, and then plus z minus 4, and 3 minus 2 is 1. So it will be equal to 0. So we'll get equation of this plane as 3x minus 2y plus z, and this is minus 8 minus 4. So it will be minus 12 equals 0. So this is the equation of plane CDE. Now we need to find point of intersection of this line and this plane. So this point P, it must lie on this line and it must also lie on this plane. So from here we'll get this value of lambda. So if we put this point in this equation, we can write 3 plus 3 lambda minus 4 plus 2 lambda plus 1 plus lambda minus 12 equals 0. Now this is 3 plus 2 plus 1. So it will be 6 lambda, and this is 3 plus 1, 4, L cancel. So it will be equal to 12. Value of lambda is 2. Now if we put lambda is 2, then we'll get this point P as 3, 0 and 3. So the point R, where this line, it intersects this plane CDE, will be given by 3i plus 3k. Now here the question is, we are given 3 points P, Q and R, and the first question is find area of triangle having P, Q and R as its vertices. Now for this, what we'll do is we'll find PQ. Now PQ is Q minus P, so it will be 0i plus j plus 2k, and we'll find PR, which is I plus j plus 4k. Now if we find PQ cross PR, will be this IJK. Now this is 0, 1 and 2, and this is 1, 1 and 4. Now if we solve this, we'll get this as 2i and then plus 2j minus k. So area of this triangle PQR will be 1 by 2 into magnitude of PQ cross PR. Now this is 1 by 2 into, its magnitude is under root of 4 plus 4 plus 1, which is 3 by 2. So area of this triangle is simply 3 by 2. Now this second part is, give the equation of plane through PQR in the form of AX plus BY plus CZ equals 1. Now, normal to this plane is given by PQ cross PR, and this we have already worked out. So it will be 2i plus 2j minus k. So direction ratios of normal, it is 2, 2 and minus 1. Now once we have direction ratios and we can take any one point, we can write equation of this plane as 2 into x minus 1 plus 2 into y minus 0 minus 1 into z plus 1 equals 0. So it will be 2x plus 2y minus z. Now this is minus 2 minus 1. So it will be simply 3. Now we can write this as 2 by 3x plus 2 by 3y minus 1 by 3z equals 1. And that is the equation of this plane in the form ax plus by plus cz equals 1. Now this part C is, where does this plane in part B intersect the y-axis? Now y-axis intercept will be given by x upon a plus y upon b plus z upon c equals 1, and we are looking for b. Now y-axis intercept in this case is simply 3 by 2. So it will intersect y-axis at 0, 3 by 2 and 0. And finally it says, give parametric equation of line through R which is perpendicular to the plane in part B. Now any line which is perpendicular to the plane will be parallel to its normal. So direction ratios of this line will be same as direction ratio of the normal, which is simply 2, 2 and minus 1. So once we have direction ratios and we have this point which is R and this point is 2, 1 and 3, we can write this equation as x minus 2, y minus 1, z minus 3 upon, now direction ratios, they are 2, 2 and minus 1. And since we have to write this equation in terms of parameter t, we can write this as x equals 2t plus 2, y equals 2t plus 1 and z equals minus t plus 3. So this is the equation of line passing through R and perpendicular to the plane in parametric form. Now the question is, find the value of p so that these two lines are in the same plane, and for this value of p, find the point of intersection and equation of the plane containing them. So we have this plane which contains these two lines. Now in order to write equation of this plane, we need a point. So we already have a point and we need two parallel vectors. So we have two parallel vectors, minus 3, 2, 1 and 1, minus 3 and 2. So we can write equation of this plane as x, y minus 7, z plus 7, and this is minus 3, 2, 1, and here will be this 1, minus 3 and 2, and will be equal to 0. Now we solve this, we'll get this as 7x. Now here will be minus 6 minus 1 and plus 7, y minus 7, and here will be this 9 minus 2, 7, z plus 7 equals 0. Now we'll cancel this 7, plus 7 and minus 7 will also cancel. So equation of plane containing these two lines will be simply x plus y plus z equals 0. Now first we need to find value of p. Now since this line, it lies in the plane, its point which is 1, p and minus 2 will also lie on this plane. So it will be minus 1 plus p minus 2 equals 0. That means value of p is simply 3. So now we have equation of plane and we also have this value p. We need to find coordinates of their point of intersection. Now for point of intersection, what we'll do is we'll take their parametric coordinates. Now say this is lambda and this is t. Point on this first line, it can be expressed as minus 3 lambda minus 1 will be 2 lambda plus p, and p here is 3, and then lambda minus 2, and on this second line will be t minus 3t plus 7 and then 2t minus 7. Now we are looking for point of intersection. That means the point which lies on both the lines. So we'll equate these two coordinates. Now from this first one we'll get t plus 3 lambda equals minus 1. From this second one we can write 3t plus 2 lambda equals 4. Now we'll multiply this first one with 3. So we'll write 3t plus 9 lambda will be equal to minus 3. Now we subtract first from second. We get 7 lambda equals minus 7. So value of lambda is minus 1. Now if we put lambda is minus 1, we'll get this point of intersection, and this point of intersection will be 2, 1 and minus 3. So now we have value of p, equation of this plane and their point of intersection, which is what we need to find in this question. Now the question is, find the foot and hence length of perpendicular from this point to this line. Now we have this line which is x minus 15 by 3, it is equal to y minus 29 by 8, and is equal to z minus 5 upon minus 5. So we have to make coefficient of z as 1. Now we are given this point P, which is 573. And from this point, we have dropped a perpendicular on this line. Now we need to find coordinate of this point and say this point is Q. Now we can take this point Q in terms of perimeter lambda. We can write this point Q as 3 lambda plus 15, 8 lambda plus 29, and minus 5 lambda plus 5. Now we can also write direction ratios of PQ. Direction ratios of PQ, they will be 3 lambda plus 10. Now it is 8 lambda plus 29 minus 7. So it will be 22. And then minus 5 lambda plus 5 minus 3 is 2. And direction ratios of this line, they are 3, 8 and minus 5. Now since these two lines, they are perpendicular, their dot product is 0. So we can write 3 into 3 lambda plus 10, 8 into 8 lambda plus 22, and then minus 5 into minus 5 lambda plus 2 equals 0. Now this is 9, 64 and 25, which is 98 lambda. And here this value is plus 196 equals 0. Value of lambda here is minus 2. Now once we have this lambda, we can write coordinate of this point Q. So if we put lambda as minus 2, it will be minus 6 plus 15. So it is 9. Now this is minus 16 plus 29, 13, and then 10 plus 5, 15. So coordinate of foot of perpendicular is 9, 13 and 15. Now we need to find this shortest distance. Now this shortest distance is this distance PQ, and it will be 9 minus 5, 4. 4 square is 16. 13 minus 7, 6. 6 square is 36. And then 15 minus 3 is 12. 12 square is 144, which is under root of 196, and which is 14. So this perpendicular distance is 14 units. Now the next part, it says find equation of plane in which this perpendicular and the given straight line lie. Now for this plane, we need point and two parallel vectors. So we already have this point, which is x minus 15, y minus 29 and z minus 5. And then we have this one perpendicular vector, which is 3, 8 and minus 5. And we also have this second perpendicular vector, which if we put lambda is minus 2, it is 4. Now this is 22 minus 16, 6, and then 12. So direction ratios of this line are 4, 6 and 12, or we can write it as 2, 3 and 6. So we'll use 2, 3 and 6. Now this is 48 plus 15. That will be 63. So we can write this as 63 into x minus 15. Now this is 18 plus 10, 28. So it will be minus 28 y minus 29, and this is 9 minus 16, and 9 minus 16 is minus 7. So it will be minus 7 z minus 5 equals 0. Now we'll cancel everything with 7. Now this is 4 and this is 9. We can write this equation as 9x minus 4y minus z. Now 15 into 9 is 135. 135 and then 4 into 29 and then plus 5. So this value is minus 14 equals 0. So equation of plane containing this line in perpendicular is 9x minus 4y minus z minus 14 equals 0. And that is the answer to this question. Now the question is, we need to find equation of a plane which passes through point of intersection of these two lines and is at a greatest distance from origin. Now first what we'll do is we'll find point of intersection of both the lines. Now we'll take this point on this line in terms of parameter lambda. So a point on this line will be 3 lambda plus 1, lambda plus 2 and 2 lambda plus 3, and a point on this second line in terms of parameter t, and it'll be t plus 3, and this is 2t plus 1, and this is 3t plus 2. Now since we are talking about point of intersection, this point will lie on both the lines. So we'll have a point at which these two coordinates, they'll be same. So we'll get this first equation that 3 lambda minus t equals 2. From this second one we'll get lambda minus 2t equals minus 1, and this third equation which is 2 lambda minus 3t and is equal to minus 1. Now what we'll do is we'll multiply this first equation with 2, so it'll be 6 lambda minus 2t and 4, and then we'll subtract this first equation, so it'll be 5 lambda equals 5. So value of lambda is 1, and if we put lambda is 1, we'll get t as 1, and if we put 1 and 1 here, it satisfies this third equation. So basically these two lines, they'll intersect, and they'll intersect when the value of lambda is 1 or when t is 1. So their point of intersection, it will be 3 plus 1 4, 1 plus 2 3, and then 3 plus 2 5. So these two lines, they'll intersect at this point. Now basically we need to find equation of the plane which passes through 4, 3 and 5, and which is at a maximum distance from origin. Now there will be many planes which can pass through this point, but then the plane which will be at the maximum distance from origin will be the one for which this OP, it is a normal. So the plane at a greatest distance will be perpendicular to vector OP. So direction ratios of normal, they will be 4, 3 and 5, and we also have this point 4, 3 and 5. So we can write this equation as 4 into x minus 4 plus 3 into y minus 3 and plus 5 into z minus 5 equals 0. So it will be 4x plus 3y plus 5z, and here it will be 16 plus 9 25, 25 plus 25 50. So that is the equation of plane which is at a greatest distance from origin and passing through point of intersection of two given lines. Now here the question is, if the straight lines are coplanar, then the plane containing these two lines is. Now what we'll do is we'll write equation of this plane, and for this equation we need a point. So we can choose any one point. We'll choose this one. Say it is x minus 1, y plus 1, z, and then two direction ratios which are 2k and 2 and 5, 2 and k, and it'll be equal to 0. Now we can write this as k square minus 4 x minus 1 minus y plus 1 into 2k minus 10 and plus z, and there will be 4 minus 5k, and it is equal to 0. Now point on the second line which is minus 1, minus 1, 0, will also lie on this plane since both the lines, they are coplanar. So we'll put this point here. So we'll get k square minus 4. Now this is minus 2. Now minus 1 plus 1 will be 0, and z is also 0. So from here we'll get the value of k as plus or minus 2. Now if we take k as plus 2, now this is 0, and here will be 4 minus 10 minus 6 minus minus plus, so it will be 6y plus 1, and here will be 10 minus 4 minus 6z equals 0. So this equation will be y minus z equals minus 1, and that's your option C. And if we take k as minus 2, so again it will be 0. Now this is minus 14 plus 14, so it will be 14y plus 1, and here it will be 10 plus 1 14, so 14z equals 0. So now we'll have this equation as y plus z equals -1, and that's your option B. The correct options are B and C. So here we have values of k, and we also have equation of planes. Now the question is, we are given two lines L1 and L2, and we are also given two planes P1 and P2. It says let AX plus BY plus CZ equals D be equation of plane passing through point of intersection of lines L1 and L2 and perpendicular to planes P1 and P2. Then we need to match the values of A, B, C and D. Now first what we'll do is we'll find point of intersection of two lines, and for this we'll use parametric coordinates. Now say this is lambda and this is t. Now point on this first line, we can write this as 2 lambda plus 1 minus lambda and lambda minus 3, and this point of intersection will lie on the second line also. So it will be t plus 4, t minus 3 and 2t minus 3. Now if we compare it, we can write 2 lambda minus t, it is equal to 3, and then lambda plus t is also 3, and then we have lambda minus 3 equals 2t minus 3. Now if we add them, we'll get lambda is 2, and if we put lambda as 2, we'll get t as 1. Now we need to verify this third equation. So if we put lambda as 2, we'll get -1, and here it will be -1. So that means these two lines, they'll intersect, and their point of intersection will be given by either we can put the value of lambda or we can also put value of t. Now this is 5, -2 and -1. So these two lines, they'll intersect at this point, 5, -2 and -1. Now we need to find equation of this plane which passes through this point. So we'll get x minus 5, y plus 2 and z plus 1, and this plane, it is perpendicular to two planes. Now if it is perpendicular to planes, then it will be parallel to their normals. So now we have two parallel vectors, and which are 7, 1, 2 and 3, 5 and -6, and will be equal to 0. Now this is -6 minus 10, so it will be -16 x minus 5. Now this is -42 minus 6, so there will be +48 y plus 2, and then it will be 35 minus 3, 32 z plus 1 equals 0. Now we'll divide everything with 16. So this is 16, this is 3, and this is 2. So we can write this equation as x minus 5 minus 3y minus 6 minus 2z minus 2 equals 0, or x minus 3y minus 2z will be equal to 13. Now we have to compare it with ax plus by plus cz equals d. Now a is 1, so basically this p, it matches with 3. Now b is -3, so q matches with 2, c is -2, c matches with 4, and d is 13, so d matches with 1. So this is 3, 2, 4, 1, and that's your option A.